In this lecture, I'm going to unpack the syntax of Pytorch a little bit more. And so far, we have been working with things like ordinary least squares regression with Pytorch, logistic regression, artificial neural networks, and so on. And what I'm going to cover are things that we've already encountered before. But now in this lecture, I'm going to unpack them. So you can import torch optim as optim. Now, this is the key thing that you must have encountered it a few times and you must be wondering what this is about. So, import torch.nn as nn. Now, this module, torch.nn, is the cornerstone of designing neural networks in Pytorch, and indeed, it came into play when we were working with things like linear regression as well. But now, after this point, this is something that you'll encounter a lot, and this particular class, it can implement anything from a simple artificial neural network that we encountered all the way to deep neural networks to convolutional neural networks, which will come further on in the course. So everything revolves around this package. The nn.module class has methods, two methods that we have to override, and we've already encountered those methods, but now we'll just unpack them a bit more. The first is the init function, and every time we use this class, you've seen that we use this function, and this function is invoked when you create an instance of nn.module, and this is where we define the different parameters of a layer such as filters, kernels, and that's something we'll do later on. In this example, we are just going to keep it very simple so you know how the init function works, and that is followed by the forward function, and this is in here you define how your output is computed, and indeed depending on the nature of the computations you're doing, we can have more functions beyond that, but these are the two most important methods that we end up encountering with nn module. So now we are just going to, in this example, we'll just stick to multiplying the input by a number. So we define the class, and I call it example layer. I call nn module, and as soon as I call nn module, I have the init function, which I have to essentially, this is going to be invoked every time we call nn module. Def init self param, super.init self param, and obviously these are just a syntax that you have to bear in mind. And now I'm going to define the forward function. So def, which stands for forward, for function, and I'm going to just call it forward. And self x, because we are just going to have, and we are just going to return a simple multiplication simple multiplication in here. So return x into self dot param, and obviously depending on the nature of the problem, the forward function can contain lot more arguments and parameters than what I'm putting in here right now, but right now we are just doing a multiplication example, so that's it. So now output my object, and now we are going to just put in the tensor, and obviously we can create a tensor by saying torch.tensor. So now we can print the output, and basically this is how in the forward function, so The def init parameters, these are just basic initialization parameters that we end up using, and in the forward function I just define a multiplication operation, and depending on the nature of the problem we could indeed end up defining more complex operations in here, but right now we'll just try to do a multiplication operation